prototype successfully passed all aging tests, high, low temperature vibration tests, and comprehensive ICT evaluations. However, 1 month after mass production began, a series of issues emerged, including black screens, failures to power on, occasional restarts, and board burnout. When defective units were returned to the factory, inspection found intact solder joints with no abnormalities in circuit components or programming materials. Departments shifted the blame among themselves, but the root cause was primarily latent solder defects. Such delayed failures represent the most frustrating challenge in hardware mass production. This type of failure exhibits 3 hallmark characteristics. It has a latent period, where new units show no abnormalities during short-term testing, but failures emerge collectively after prolonged operation under load. Its occurrence is closely linked to temperature, vibration, and load conditions. Logistical handling shocks, thermal cycling, and sustained overheating significantly increase the defect rate. Defects in returned units are difficult to reproduce, as solder joints only exhibit marginal conduction capability, yet normal operation can be restored through static testing or brief power on. The root cause of these failures is not visibly obvious solder joint defects, but rather BGA voids, micro solder joint issues in power devices, internal cracks within solder joints, and localized poor wetting. Under the combined effects of high current main control circuits, power MOSFETs, current carrying loads on thermal pads, thermal stress, and mechanical stress from temperature fluctuations, these voids reduce both conductive and thermal surface areas. Prolonged operation creates a vicious cycle of overheating and increased resistance. Coupled with thermal shock and vibration, solder joints progressively deteriorate and crack, ultimately leading to interruptions in the power supply circuit and complete device failure. Similar cases have occurred with industrial power modules. Despite passing all tests, batch failures emerged after 1 month of use, with BGA voids and cracks only identified through X-ray inspection and metallographic analysis. ICT and flying probe testing methods can only detect open or short circuits, but cannot identify internal micro defects. Static conduction does not guarantee long-term reliability, and electrical tests alone cannot fully ensure solder quality. Source control implementation measures are divided into 6 aspects: optimizing the reflow soldering profile by adjusting temperature rise rates, holding time, and cooling rates for PCBs and components to reduce thermal stress that contributes to void formation, refining stencil window design and solder paste application to ensure balanced solder volume on thermal pads and BGA components, conducting regular X-ray inspections of BGA and power devices while establishing clear thresholds for void detection rates, performing metallographic cross-section analysis when changes are made to new products, materials, or equipment to visually examine solder interfaces and cracks, extending reliability testing protocols to include thermal cycling, thermal shock, full load start-stop cycles, and random vibration tests to detect latent defects early, establishing a closed-loop system for post-sales failure analysis that prioritizes identifying thermal sources and high-current solder joints prone to delayed failures, supplemented by X-ray imaging and cross-section analysis. No matter how advanced the circuit's software or materials may be, latent solder defects can directly compromise mass production reliability. Mass production control should not rely solely on electrical testing. It is essential to incorporate reflow process optimization, stencil design, X-ray sampling inspections, cross-section verification, and extended reliability tests into standard procedures, thereby avoiding the need to identify internal solder defect risks only through post-sales repairs. From planning and design to BOM preparation, debugging, FA troubleshooting, and issues with electronic components or hardware, always consult ICwantOpen first.